Thanks. Hello, everyone. I'm very happy to be here, first time at GAIA. And today I'm going to be presenting about synthetic data for computer vision problems when real annotation is too expensive. Oh, sorry. Okay, the agenda for today is I'm going to start with a brief introduction about synthetic data in computer vision. Then I'm going to go through some tools that we can use to create synthetic data. I'm going to present some cases where we've used synthetic data at Model I, and I'm going to end with some final thoughts. So, as many of you know, computer vision has pretty much revolutionized the way we interact with technology. Uh, in the last few decades, computer vision and deep learning models have advanced in a very large pace, from applications that we use right now, like self-driving cars, face recognition in our phones, and medical imaging. However, most of this advancement is thanks to the availability of large, high-quality label datasets. If you work in machine learning and computer vision, you probably know about ImageNet, Coco, or Berkeley Deep Drive. However, in our problems in real life, we not always have the access to these large, high-quality datasets. And this is because creating a high-quality dataset, it often becomes very time-consuming to collect, label, verify the labels of our dataset. This makes it also very expensive, subject to bias, and in some cases, it raises some concerns due to privacy or copyright. For example, when using data from medical purposes. So how do we overcome the limitations of real data when at the same time we want to train these deep learning models for computer vision that require a large amount of label data in most cases? Well, one solution that has become more and more popular within the computer vision community is using synthetic data. And synthetic data is all the data that is artificially generated by a computer algorithm. The benefits of using synthetic data is that you can guarantee perfect labels. Since you're creating objects or the image, you can know their characteristics and by then guarantee perfect labels. And probably also do labeling that might be more difficult for a human to do, like labeling pixels, for example. You can also control how wide and diverse your data is, how varied it is, and also probably simulate scenarios that are very rare to see in reality. It allows you to have a much faster iteration over new data. It contrasts to real data where you have to, if you need new data, you have to go, collect data, label it, verify that the labels are correct. Here, once you have an algorithm or your system that builds synthetic data, it's much faster to go back, ask for more data. And with that, you can say you have unlimited amount of data that you can create. Okay, so now I'm gonna go through some approaches that one can use to generate synthetic data. There's three main approaches. The first one is through using generative models. For example, GANs, variational autoencoders, or diffusion models. One can also use simulation tools. This means computer graphic techniques. These techniques allow us to simulate more physical properties. We can also change lighting, for example, texture, movement of an object. And there's also hybrid approaches, where one can, for example, use a generative model to create the main image and maybe go back and add some special lighting. Synthetic data in computer vision is already applied to many different applications. For example, object recognition, eye tracking, and full body analysis. And there's also available some open source datasets that are created only with synthetic data. One of the most famous one is Syntax. You can see it in the image. Syntax is a dataset where they have randomized text and placed in backgrounds from different sources. And this is mainly used for text localization. There's also CG. This dataset is composed by more than 45,000 images in 3D. And this is mostly for indoor scenes. There's Cynthia, where it's used for segmentation and is also 3D images, but for urban scenes. One can also use simulation environments. Carla, is an open source simulation environment specifically used for autonomous driving. There's also other tools like AI Tutor. This is a tool made by the Allen Institute for AI. And this tool is specifically made for simulation of AI agents, as well as NVIDIA Isaac Sim is also used for robotic applications mostly. And there's other simulation tools that allow you to have a bit more flexibility of creating your environment while also having some features for machine learning annotation like Unity perception and Blender Proc. So is synthetic data better than real data? Well, in 2021, there was a paper published by Microsoft researchers called Fake It Till You Make It. And this paper focuses on training a deep learning model only using synthetic data for 3 main tasks: face parsing, landmark localization, and eye tracking. And they compared this model to a model trained with only real data. And their findings were that their model trained with only synthetic data was performing very similar, in some cases even better, than the model trained with real data. Another very important paper in synthetic data is StyleGAN. The main idea of StyleGAN is to generate high quality datasets, synthetic datasets, by modifying different style vectors that control aspects of an image style. For example, spatial arrangement of objects, color, and texture. And in 2021, a paper named Segmentation in Style used StyleGAN 2 and a clip model to create synthetic images and segmentation masks without any human intervention. They train a model for segmentation, and they train this using only the synthetic data, and they compare it with other models that were trained with real data in a supervised way and semi-supervised way, and they realized that their model performed as good as the supervised model trained with real data. Obviously, not everything is good with synthetic data. There's some cons. For example, domain gap. It can be quite difficult to create synthetic images. Depending on your application, it can become more complicated to simulate a real scenario. And this can make it also computationally expensive, especially if you do, for example, simulations. And it might require a lot of expertise in the domain. Okay, now I'm gonna go through some use cases that we have where at Model I, where I work, we use synthetic data. I'm gonna focus only on the use of synthetic data. And the first case was in gaming. If you want to know more about this project, we have a blog post available in our website. It was specifically for esport tracking. The gaming startup came to us. They wanted to provide some information about game tournaments. And the objective was to predict some events in real-time video streamings of tournaments. For that, we use synthetic data specifically to identify the different icons that you can see in your left and right bottom of the screen. This is a use case for CSGO, Counter-Strike Global Offensive. We wanted to know what happened with the players, so we wanted to identify these different icons. And for that, we use a simple approach with synthetic data. We collected these different icons that could appear in the screen. We did some randomization. We collected also images from the video game itself and some images from open source data. And we pasted these icons in different parts of the image. We did some augmentation. And then we use this as our data set. Since we know the localization and where we put the icons, we can create our segmentations mask and bounding boxes and use that as our target. Another case where we use synthetic data was for anomaly detection, specifically for saggy electric wires. The objective of this project was to detect faulty guide wires in electric grid. As you can see here, you can see an image with a guide wire that is a bit saggy. In this case, the image has an insulator in the middle. This is not always the case for guide wires. The insulator also doesn't look like this all the time. As you might think, yeah, there wasn't available data sets that we could use. This is a very specific problem. There were some available data sets for general grid lines, but not for this specific cable that we wanted to identify. So our solution was to create synthetic images using a simulation in Blender. This is how a image looked like. As you can see, we also simulate the insulator in the middle, and we added some cables that we didn't want to identify, but that you usually see when you want to look for the guide wire. This is another example. Because we created the synthetic data, we could simulate guide wires in very different environments. Environments that maybe we didn't have enough images for, like when there's snow in the background. This is some results that we got. The bottom image is a prediction mask, and the top is the real image. As you can see, we get quite a good mask together with the insulator. Without the synthetic data, our model was performing pretty bad. So using this type of synthetic data allowed us to have a better mass definition and increased performance of our model. Another case where we use synthetic data was for gas tank leak detection. So the main objective of this problem or project was to identify gas tank leaks in cars. For this case, we had also some real data available, but there were some cases where the model was not performing well. For example, when the lid had a sticker on it, and when the lighting was reflecting a lot from the car, it was very difficult for the model to perform in these rare cases. So we decided to do some synthetic data using a simulator called Unreal Engine. This is how one of our synthetic data looked like. We applied some lightning in the back and we created some more difficult conditions. And this allowed our model to improve its performance on these special cases where we realized that the model wasn't performing well. Another problem where we use synthetic data was for tree ring segmentation. So the objective of this project was to count the rings to determine how old a tree is. This is a very, very specific problem. There's not available data sets that are focused on this problem. So we had a lot of limitations. And annotation of tree rings is very difficult. You need someone that is specialized, that really knows how to count the rings on the tree. So our solution was to create synthetic data using generative models. Here you see a general workflow on how we created the synthetic data. We started with a drawing of rings. We use a generative model to create a synthetic image of a log face of a tree. And because we knew the starting drawing, we could know the ring mask of this tree. And then we created another algorithm to count the amount of rings. That is what our objective was. Okay, some final thoughts about synthetic data. Well, sometimes you don't need a synthetic data that is very adapted to your domain. Sometimes it's as easy as maybe paste some icons in different backgrounds, but sometimes it can be much difficult to close this domain gap. So consider what's the cost between labeling real data and generating synthetic data, because it can be quite expensive depending on what's your application. There's also other solutions like supervised, self-supervised, and few-shot learning. And synthetic data can help you to, for example, tune a model in certain cases that you probably don't see in real life that often. So maybe you can just do some part with synthetic data to simulate difficult cases. And that can improve a lot your model. And finally, it's also good to have a reliable test dataset that you can test your synthetic data on it to know that it's actually a good representation of a real scenario. And that's it for my presentation. Thank you.
Thank you very much, Abgeiba. I have a very, very quick question, following up on the test data. But if you only use synthetic data for difficult cases and dangerous settings, like showed, how can you make sure it works in real settings? Is it?
Yeah, I think in that case, it's very important to have a very good test set that is real data, probably, that is very representative of your application, that can really test your model.
Thank you. Yes, sorry, the questions from the audience.
It will be? Okay, there we go. I had a question on generating data on the fly. Do you have any thoughts on that? Compute time for creating a batch versus training on a batch, for example, for these kind of computer vision problems?
Yeah, we actually try to generate some synthetic data on the fly. Some cases are much faster, but for example, with simulation, it takes a long time. It's quite computing exhausting, and probably you are not able to do it on the fly. Yeah.
Do we have more questions? Please feel free to raise your hands. Yes, we have one here. Danilo.
Thanks. I have a question on the generative part. When you use generative models to create synthetic data, so do you have a way to enforce that the images have the right properties? So, like in your example with the tree rings, so you start out with a mask or a sketch. How do you make sure that the generated image have that number of tree rings? Just as an example.
Yeah, well, we use part of real images, but yeah, there's some process in the middle that I cannot explain here, but yeah.
Other questions for Abgeiba? Can I go back to my questions before? Because I feel like I have more. So let's say that I am quite happy with my test data. Is that enough to validate? How do we actually validate and evaluate these systems? How do we know that they're good enough?
Yeah, I think you maybe need to do a lot of exploration on tests on real cases. I don't know if we're at the point where we can actually create a fully trained model with synthetic data. There were some cases, but they had a lot of data, 3D simulations, very, very similar to the real cases. Depending on how you can simulate your case, on how much your image needs to be close to the real case, there could be some domain gap. And yeah, I think the best way to do it is testing your model a lot with real data and with edge cases. And depending on your application, maybe you don't need to have a very, very reliable model, but maybe if it's a case of security, you need to be very sure. Yeah, it needs to be tested a lot.
Exactly, I was thinking about that.
Yeah.
Do you have any juicy example of domain gap that you encountered? I understand that you don't have an image to show us, but do you have any examples of when this has been a problem for If you can think of one, of course.
Yeah, I think the project where the tree where we use generative models, that project is still in progress. I think there's still a lot to do and still some domain gap to fix. For example, we have these rings that are perfectly rounded, but in real life, sometimes the rings in the tree are not center in the middle. They don't look exactly like our image. And yeah, in these cases, I think the model still doesn't perform that well.